welcome. Today we're biting off a big bite of fractional exponents. Day one was a little rough, so we're going to go through a couple examples to make sure we understand that transition, that two-way street from fractional exponents to radical form and vice versa. And then we're going to show a variety of ways to use them. You need to find out a method that works best for you. You need to be able to diagnose the scenario and come up with the path of least resistance. There's a lot of ways to solve these, but there's usually one way that's most beneficial, or at least a way that you prefer, and you need to find out which method you prefer, okay? So before we get started, let's just review. Going from a fractional exponent to a radical form. If you have any number x to the a over b power, the a is the exponent on the inside, the b is the index, okay? So right off the bat, we're gonna do an easy one. 5 to the 1/3. This would become cube root 5 to the first. Now, do you have to put the 1? No. But I just want to show that quick and easy from fractional exponent to radical form. Now, we're going to do another one from radical form into fractional exponent. It's very important you identify every single item's exponent before you do this. That 2 has an exponent of 1, so it will become 2 to the 1/5. But that a is a little different. A is a 10, so it'd be a to the 10 over 5, which is 2. So you might have them all under the same radical, but when you write it in exponential form, they're going to have a different exponent, and that is okay. Lastly, b as well to the 1/5. Okay? It's just a real quick precursor on how to move back and forth. Now let's start evaluating some things. They give you negative 256 to the 3/4 power. First thing I want you to identify, that negative is on the outside, right? That 256 is not negative. It's, remember, order of operations. Exponents come before multiplication. This is technically negative 1 times 256 to the 3/4. So ignore that negative till the very end. I'm only going to look at 256 to the 3/4. So that's what we're going to attack first. Now, yes, you could go straight to 4th root of 256 to the 3rd. That's going to give you some big numbers. I'd rather play around with my powers. 256 is 16 squared. Let's see if that gets us somewhere. So I'll have 16 squared to the 3/4 power. Now, yes, I am ignoring that negative because I know that'll just be whatever I get times a negative 1. We'll come back to that. Well, notice something. Power to power, this is 2 over 1, no cancellation. I now have 16 to the 3 over 2. I like that. It was pretty easy. Maybe we can do it again. Notice something about 16? It's 4 squared. So let's continue this using, now I haven't even touched a radical because I don't need it. I'm staying fractional exponents. 4 squared to the 3 over 2. Oh, shoot! I hit another round of cancellation and it's just 4/3. Isn't that nice? Isn't that where we want to be? Somewhere that we can just do it in our head. I looked at my numbers and I played with its powers to get it to a very, very manageable operation. 4 to the 3rd power is 64. Oh, don't you sleep. That was still waiting. Negative 64. Done. Now, that was my method. Could you have gone radical? Yes. Would it have taken more time? Yes. This, to me, was one of the fastest ways to slow play it. Now, keep in mind, you could have gone straight to 4 to the 4th, canceled and gotten there. I don't think many of you know your 4th powers yet. It's okay if you do, use it, but most of us can at least identify squares and work our way there. All right, a couple things going on here. Notice we have the same base. Same base, so we're allowed to add our exponents when we multiply. More good news, your exponents have the same denominator. So I am going to quickly make this 27 to the 5/3. Everybody okay? Now, there's a lot of ways you could do this. A lot of ways. I see some people going, okay, so that's 5 over 3, that's 1 2/3. So they want to go to an exponent, right into radicals, and pull out a 27. If that was confusing to you, that means that's not the method you should take. I'm going to play around with 27. That is what? Hopefully you can recognize 3rd powers. That's 3 to the 3rd. Good things are going to happen. Think about this. It's 3 to the third to the 5 thirds. Oh shoot, look what happens. Cancel, cancel. And it becomes 3 to the 5th. You can evaluate that, okay? 3, 9, 27, 81, 270, 243. Multiplication stuff. Done. Now again, can you go radical? Yes, but I hope that we're using the new skill, the fractional exponent, to make our jobs a little easier. I didn't have to touch a calculator. Now, if you have a calculator, I understand if you want to do 27 to the 5th power and then cube root it. All right, what if you didn't have one? You better know how to do this. Lastly, okay, let's go the back way. I got 8 to the 5th power, and they're taking the 10th root of that. Well, right away, I'm going to think about the inside a little differently. I think about 8 as 2 to the 3rd power, okay? So I'm going to write 10th root of 2 to the 3rd power to the 5th. Right, same thing, but I'm using my new skills of trying to play with powers. So they're really taking the 10th root of 2 to the 15th. Doing okay? 10th root of 2 to the 15th. Now I'm going to transfer over into that radical. From the radical into the fractional exponent. So they really want 2 to the 15 over 10. That fraction is begging to be reduced. So let's do it. 2 to the 3 over 2. That is much, much nicer. And now I'm fine with it. I'm really just going to take the square root of 2 to the 3rd. Right? Now we're going back to radical. So that means I have 3 2's here, which means one of them comes out, leaving me with one on the inside. And that is your final answer. Remember, I said if it starts in exponential, I want you to try to primarily end up with exponential. Now, if it comes out to be a whole number, awesome. If it stays radical, if it starts radical, try to end up something radical if it's possible. Quick tutorial on some examples from your homework and refreshing the back and forth between exponential and radical. Hopefully it helps.